Hello, this is Retro Marky. Now I've decided to do a new mini series and I'm delving more into basic electronics as opposed to my usual videos, and I want to introduce you here to something called the 555 timer. Now this is a tiny weeny little chip with 8 legs, and we're going to use that for the fundamentals of starting to create a computer from scratch. Now this series will take me quite a long time and maybe even years, so please bear with me. Now what I want to show you first is, now there are much better explanations of this on the internet. I'll put some links in the video, but I'll try and explain this as best as I can, especially for the layman. So on pin 8 here we've got a voltage of 5 volts and we've got 3 5k resistors, thus the name 555 timer, and that's connected to ground on pin 1, and these basically are voltage dividers. So this is reducing to 2/3 voltage and this to 1/3 voltage. Here we also have 2 comparators, and down here a flip-flop, and what basically happens is, using some capacitors and resistors, these 2 comparators compare 2 inputs, plus and minus, on this diagram here, and depending on their state can either set an output or reset, go round to here and to this reset pin. Now the upshot of that is we've got a system where voltage is being basically manipulated down by 2/3, down by 1/3, down to 0, and then a capacitor, which you'll see on my breadboard in a second, will be start to charge up again, and this circuit again will manipulate these comparators, and the upshot of that is you'll get a very consistent square wave, which is going to be a simple computer clock timer. Now apologies, but I did want to try and describe how this works in detail, but as I said, there are better sources on the internet, and I'm still trying to get my head around all of this. I more or less understand it, but I recommend reading or watching videos 4, 5, 6 times to really get your head around it. But let's have a look at the actual circuit itself and see what this does in reality. So here's my breadboard here, and just to point out, we've got a number of resistors, a small and a very large capacitor. This one's too large, but it will work for my needs at the moment. 2 555 timer chips, which are probably quite difficult to see, and a couple of buttons. Over here another capacitor and a couple more resistors, and this is called another resistor here, and this is called a potentiometer, which actually is basically a variable resistor, so this can vary the resistance. Here we've got something that's a bit overkill for this project, but I was using my bench power supply, but the thing's noisy and I don't particularly like using it for something like this, so I came up with the slightly genius idea of using an Arduino, which has a convenient voltage out here, and we're going to take the 5 volts to power the circuit from here, red being positive, white being negative. So let's switch on, and I'll give it a quick demonstration. And like I said, what I'm basically doing is I'm always on a quest to understand computers better. That will help me in troubleshooting, that will help me in repairs, and it's just something that's always fascinated me. So what we're going to do is just quickly plug in the breadboard here, and there we go. And what you should be able to see here is a blue flashing light, and notice it's very consistent. On, off, on, off, on, off. Here we've just got my little reset circuit, and we've got another thing here that I'll talk about in a second. Now I talked about a voltage, so I talked about the potentiometer. Now we've got a resistor here, so it won't go down to 0, it will restrict it to some extent, but if we turn it this way, you should notice it's a fair amount quicker. So we can actually control our clock speed. Now I want it fairly slow, or I will do in future, because if/when I get round to building a whole computer, an 8-bit computer, it's going to take a while, I'd like to be able to see what's happening to the computer fairly slowly to understand it. So that's pretty much the circuit that I wanted to show you. Now, another fun bit about this, or fascinating for me anyway, is to have a look at this on an oscilloscope, and then you can see the square wave, and also we can watch the capacitor charging. And hopefully, even though my description's been pretty primitive and not particularly great regarding the 555 timer, at least you can see how it works. You don't need to understand all of the inner workings of this, to be honest, to follow a schematic and do this. So in my case, I understand how this works and what it can do, more or less, but I wouldn't want you to use this video for any educational purposes, that's for sure. I'm really a beginner at this, so please bear that in mind when you're commenting. And let's get over to the scope. Okay, so hopefully this gives you a much better idea, and this is one of the great things about an oscilloscope, is you can actually visually see what your circuit's doing. And to give a slight quick reinterpretation of the data, so here we've got the capacitor charging and discharging and charging and discharging. You get the idea. And this probe is connected to the clock output, or the output in fact, creating the clock. As you can see, we've got these fairly, well, not fairly, they are actually consistent square waves. There's a little bit of noise here, but that's not surprising considering we're using just cheap components and things like that. And what I can do, just to finish the video, is if we change the potentiometer, so it's a little bit quicker, so you can see now the pulses between are thinner and quicker. Checking the frequency, I think my scope's having a little bit of problem with this. It says 1.4ish at the moment, and it jumped to 1.7 and 8. That might be because of the capacitors and resistors, but we've got basically around 1.4 hertz there. Let me just try slowing that down and see if it helps the scope a little bit. Okay, 919 megahertz. I reckon that's about right, actually. Although, yeah, I wouldn't bet my money on that at all. So that's basically it. So in summary, using just a few LEDs, a couple of cheap timer chips, some resistors, capacitors, I've created a computer clock. Oh, I've got a weird anomaly there. Don't know what happened there. Yeah, it seems to have gone away. So now on the other part, over here, if we press this one, you can see this green light come on, and you'll notice it doesn't immediately turn off again. Well, that's because of this huge capacitor here, which is a bit too big for this, but the only one I have right now. And that, what we're doing here is stopping any bounce. So this actually is a single sequence switch. So we can actually, so rather than the clock being astable and automatic, the switch will enable us eventually, when we've got the computer working, if and when that is, to step by step go through the instructions. And this capacitor here is preventing this switch from bouncing too many times. So once we press it, that's it, it's pressed. Even if we repress it, it doesn't keep going on and off, as you can see. And there's my reset, and that's about it really. So I just wanted to quickly show you that. I'm determined, I'm really enjoying this project, so I'm determined to keep on going, and we need to develop this clock circuit a little bit more with a couple of extra things. So I'll do that in my next video, and hopefully at some point in the near or distant future I would have built an 8-bit computer for you. So just for the record, I'm not inventing this myself. This is all coming mostly from Ben Eater on YouTube, who's fantastic. I recommend following him if you want to do this, and of course if you Google around, there are other people describing the 555 timer, because it can do many things besides what we're doing today. And there are other people who've made 8-bit computers that might be worth reading them or watching them on YouTube, whatever. I'm also going to be dabbling, might do that in the next video, not sure yet, with wiring up a Z80 and also a 6502 and having a quick look at them, there's that weird anomaly again. That is kind of bizarre. Got a little bit of overshoot there, just a tiny bit, not a problem, but anyway, not sure about that. I'll leave that as a mystery. Thanks for watching. Retro Marky out.